Good morning, it's me, Mr. Truman, back again. Going over another lesson today. Today we're going to be looking at parallelograms. And this is a quadrilateral, our whole unit's about quadrilaterals, and this is a quadrilateral that has a definition as a quadrilateral with two sets of parallel sides, meaning the left and the right, the top and the bottom, if you will, are going to be two sets that are parallel and then two sets that are parallel. Now with that comes a few other aspects of this shape that aren't part of the definition but are true statements about the overall shape. So first thing I want to go over with you is the fact that if you have two sets of parallel sides, you're going to create two sets of opposite congruent sides, meaning A to B and D and C to D are going to be the same exact length. They're going to be congruent, just like A to D and B to C are congruent. So we're going to create, just like we have two sets of parallel sides, now we have two sets of opposite sides that are congruent. We're also going to create two sets of opposite congruent angles. So angle B and angle D are going to be congruent angles, just like angle A and angle C are congruent angles. So we're going to have two sets of parallel sides, two sets of opposite sides, two separate sets of opposite angles. Whatever this is, we know this is. They're going to match. And the last thing that we talk about when we're talking about a parallelogram is the fact that when you draw a diagonal, these diagonals are not going to be the same length. From like B to D is never going to be the same length as A to C. Well, it could be, but I mean, it's not normally going to be the same length. But what they do is they bisect, meaning when this diagonal BD crosses AC, it'll cut AC into two congruent halves, bisecting it, just like it'll cut BD into two congruent segments, bisecting it. So now that we got all the facts out of the way, let's go ahead and jump in with solving some problems and putting them into use. One last thing I want to cover about parallelograms is it's kind of a generic name in the sense that it covers not just one particular shape. There's not just one parallelogram. There's actually three of them. And those would be a square, a rectangle, and a rhombus. If you think about any one of these three shapes, and you think about it in solving problems that you've done maybe in the past in other classes, like maybe like pre-algebra, you'll find out very quickly that all three of these shapes follow in this because they are of the same group. They are subsets of the group called parallelograms. All right, so jumping right in, if I ask you on this first question, what is angle A? Well, again, because of parallel lines, we talked about this the other day in our previous video on kites and trapezoids. If you have parallel lines, then you must have 180 degrees between them. So if this is 55, that means that this one has to be 125. That comes from what we learned about with parallel lines. Now, looking at some of these things that we learned, well, now we know that opposite sides are going to be congruent, but opposite angles. So if this is 125, so is this one. And if this is 55, so is this one. And that comes from being a parallelogram, being between the parallel lines. So angle A, 125, angle C, 125, and D, 55. All right, part two, example two, I put up a little, this is a perimeter talking about length, but I wrote if segment AB, so we're going down the side here, if the segment AB is equal to 15, what is the length of CD? Well, again, opposite sides are parallel, opposite angles, opposite angles, or which one are congruent? Well, opposite sides are congruent too, which I didn't write down, so I got to write that down. I think that's what I meant to write right here. Opposite sides congruent. I've been talking about that the whole time and I had it wrong. Oh well. Anyways, so knowing that this is 15. Now, they're right there. My follow-up question was, if the perimeter of, and this little symbol that you see sometimes in books, you're going to see, it looks like a little, well, it just looks like a little rectangle laying on one side, and it has that symbol followed by like 4 letters, A, B, C, D. That stands for the word parallelogram. So if the perimeter of parallelogram A, B, C, D is 70, what is AD? And of course, there's the bell. School's already out and we still have the bell. All right, well, try not to get distracted by that. If the perimeter is 70, well, that means the distance, perimeter is the distance all the way around the outside of the shape. So the distance all the way around, well, I know that we have 2 sides that are 15. And then we have 2 sides that we don't know what they are. So I'm just going to give them a letter. I'm going to call that letter X, and then we'll call that letter X. And I know that together, this should all add up to 70. Well, combining my like terms, I could come up with 2x plus 30 equals 70. If I minus 30 from both sides, 2x would then be equal to 40, and x is equal to 20. Plug that in and let's see if it makes sense. Do I have a perimeter of 70? Well, 20 plus 20 is 40, 15 and 15 is 30. We got a perimeter of 70. And again, this comes down to the way it works with parallelograms, just the features that they have. All right, moving on to number 3. Back to solving again. Let's look at example number 3. It says, what is the measure of each angle? So I need to figure out the exact measurement of each angle given this information. Well, what I know about this, when I look at these two, 3x plus 14 and 9x minus 2, I know that these are between the parallel lines, which means that those 2 items have to equal 180. So if I write it down like this, 3x plus 14 plus 9x minus 2, I know that it has to equal 180. So if I combine my like terms, 3 plus 9, I'm going to use this space over here, 12x, and then positive 14 minus 2 would be positive 12, and it has to equal 180. So take away 12 from both sides, and 12x equals 168. Well, just divide it by 12 real quick. And I get x's are equal to 14. All right, well, let's see, what can I do with that? If I know what x's are equal, what can I do? I can plug that information back in, and then I can figure out what each angle is. So up here, 3 times 14 is 42, plus 14, 42 plus 14 equals 56. Well, remember, this one and this one are the same. So this is 56, and this is 56. If I plug the 14 in over here, 9 times 14 is 126, minus 2, 124. But that means this is 124. Well, what do you think? Does this add up? Is this what we should be getting? Didn't I say from the beginning that these 2 things, this angle and this angle, have to add to 180? They do. I also happen to notice that they have parallel lines on the side, which means these 2 make 180, and they do. So again, that's just using the properties of a parallelogram to solve some problems. Let's look at this last one here for solving an angle. What is the angle B? Well, before I can solve that, I probably need to know maybe angle A or angle D or something. So what I'm going to do is I'm going to look at this and say, well, what do I know about angle A and angle D? The rule says opposite angles are congruent. That means x plus 35 is opposite, which means they're equal. So that means that I could just make them equal to each other. I could solve for x. I can add 47 on, so 35. I always check my math. Plus 47, it's after school, you never know if I'm making mistakes, is 82 degrees. Or it's 82, my bad, not 82 degrees. I haven't plugged it in yet, so it's not degrees. It's just x's are equal to 82. Well, again, I need to know this angle, so I better figure out this one first. So substituting my value in, 82 plus 35 gives me 117, which means this one's 117. And what do I know about this one and this one, or this one and this one? They gotta make 180. So go ahead and minus that from 180 and you get 63, which means this is also 63. And I like to make sure that I fill in as many blanks as I can all the time, even when they're not exactly what they asked me for. It's just a good habit so that as you fill in information, things just automatically kind of fall in place. All right, last one, and then we'll wrap this video up on parallelograms. What is PR, the distance from P to R? Well, I have no idea. But what I can do is I can look at the problem and go, what do I know about S to Q? Not much, but I do know one thing. This is a parallelogram, and these are diagonals, which tells me that when those diagonals intersect, this segment from here to here is the same as this one, because they bisect. So if I write that out, and I can say, well, 4x plus 24 has got to equal 40, and minus 24, 4x is equal to 16. X is equal to 4. Super, plug that in. I already knew this was 40, which meant this one over here is 40 anyways. But let's plug that 4 in right here. All right, 2 times 4 is 8. Now I'm so we're clear, I know that if this is 40, that this really doesn't look like 8, but remember, most of these drawings always say drawing not to scale, which is like permission for me to have a really bad drawing that doesn't always necessarily match what I expect to see visually. But if I've done my math correctly and I plugged it in, as goofy as it is, we're just gonna roll with it because our math is correct. This one equals this one. If I solve for X and plug it in, substitute it in, that is the answer. Regardless of how ridiculous it looks, remember, stick to the math and not go off of appearance. Remember, just think about that little thing about how well do you know your shapes when I started messing with the appearance. All right, well, I hope that wraps it up for you. Have a great day. Bye.